Hello and welcome. This is Group 6's project proposal for the B101 assignment. NISER, being a higher educational institution focused on the sciences, has a lot of labs. And where there are labs, there are chemicals. Lots of chemicals. Chemicals that are being used and gotten rid of every day by people ranging from MSc and PhD students to professors and research scholars. Chemicals that include those that are completely harmless and those that are potentially fatal. This being the case, it would be natural to suppose that NISER has a very efficient system in place to get rid of all these, huh? Well, it turns out that that's not the case. Currently, NISER only lays stress on certain chemicals that are deemed hazardous, and no official procedure exists to dispose of other waste, including some heavy metal compounds. All these are simply stored in the campus itself. While they may not be toxic per se, the continued accumulation can cause considerable damage to the environment and to the ecosystem. The institute has been functional for a very short period of time, which means it has yet to face a situation where the amount of waste generated has taxed its storage facilities. Yet, it will inevitably face such a situation in the future, and presently, NISER is ill-equipped to handle it. Now, there's essentially two things that we could do with the chemicals. One, we just dump them somewhere. Two, we try and extract useful compounds and elements from them and reduce the toxicity of those from which we cannot. Since the first option is harmful for the environment, we're left with the latter. However, direct extraction of elements like zinc and lead from a mixture of their compounds, like that we obtain from our labs, is a tedious process that involves a lot of complex reactions which use up a lot of energy, and the byproducts created in this case would still be harmful. So what do we do to resolve this difficulty? Well, this is where phytoremediation comes into the picture. Some plants have the special ability to selectively absorb heavy metal compounds like those of copper, zinc and lead, and then break them down into simpler, less toxic substances. This process is known as phytoremediation, and the plants that have this property are called hyperaccumulators. Our project proposal involves using these hyperaccumulators to convert the chemical waste that we produce to forms from which extraction of useful element becomes much more feasible and commercially viable. Lots of studies have been done on the capability of various plants to absorb heavy metals, and the plants or trees that have shown the most promising results are sunflower, Indian willow, canola, and poplar tree. However, locally available plants in Rhodesia, such as Semaruba glauca and water hyacinth, also show hyperaccumulation property to a small extent, which is what we try to utilize in our model. Besides the experiments that have already been done by various researchers across the globe, we also try to independently verify the results on our own. We obtained zinc chloride and lead acetate trihydrate samples, added measured amounts to 3 kilograms of soil, and then planted a Semaruba sampling in it. We observed the plant for 3 weeks, during which it showed no signs of ill health, and then sent the sample to Odisha University of Agriculture and Technology for soil testing. However, a technological delay meant that we couldn't get the results on time. In spite of this, that the plant can withstand high concentrations of lead is in itself an exciting result, for most other plants would have simply died.
Hello everyone. The working model you can see here is a small-scale representation of our project on phytoremediation. You can see we have a sequence of tanks over here. In the first tank, we will add chemicals in a diluted concentration. The purpose of diluting it and having a sequence of tanks is that if the concentration of chemicals is more, the plant won't absorb more, but instead it will die off. So in the first tank, we will add the chemicals. We will keep it there for 3 to 4 weeks so that this plant can absorb to its maximum efficiency. Then we will pass on the water to the second tank where that plant also will absorb the chemicals. We will pass it to the subsequent tanks, and then the entire waste will go into this field. In this field, we will have a variety of sunflower, Indian mustard and Semaruba glauca. The purpose of having a variety of plants is that it will absorb variety of chemicals. Water hyacinth absorbs chromium, cadmium and zinc, whereas Indian mustard and sunflower absorbs lead and copper. Once the entire process is done, these plants can be taken for phytomining.
So this is the model of the phytoremediation building which we are going to propose. This is for doing phytoremediation in a commercial scale. So the main features of the building is that it has got a series of tanks like this, and in the end everything is connected to the base. So what we are going to do is that these tanks here has got floating aquatic plants, and this ground below has got land plants. And these plants are very good, are used for phytoremediation. That means these plants has the ability to accumulate heavy metals in large amount in their plant tissues and roots. So what we are going to do is that initially here in this first tank, we will be adding both the water and the we'll be diluting the waste, and we'll be adding it here. So what is going to happen is that the plant is going to absorb some of the heavy metals, and so it is definitely going to bring down the concentration of the waste to some extent. So, and after that we'll be passing it to the next tank. So here again the plant is going to absorb some of the heavy metals, and remaining will be left behind. So what we are going to do is, again we are going to pass the remaining water to the next tank, and here the plant is going to absorb some of the heavy metals. So subsequently, since this is a series of tanks, the concentration of the heavy metal is going to get reduced as the plant is going to accumulate these heavy metals. So after this, what we are going to do is that when the water reaches the last tank, we are just simply going to pass it to the field below. And this field mainly contains sunflower, Indian mustard, Indian grass, willow trees and all. So these plants are excellent phytoaccumulators. That means they can accumulate the heavy metals. So they will be accumulating the heavy metals very easily. So, and this features of this building are, it is made entirely, it's made of glass because it allows the sunlight to go through. And another feature of this building is that we'll be, for phytoremediation using aquatic plants, we'll be using water hyacinth. As you all know, water hyacinth is an alien species, and if we are exposing it to the environment, it has very chances, it will spread very easily and it will pollute the local environment. So that if you're growing it in a closed environment like this, it is never going to get outside and it is not going to spread. And another thing is that for phytoremediation, we can use different kinds of plants. So here in this space below, we can make partitions so that we can provide artificial conditions, and we can grow the plants which are not native to our country. And another thing is that this building space saves a lot of space, because for treatment using water, we need a lot of space. And since we are constructing the tanks in series like this, it is definitely going to save a lot of space. And in the end, once the plants reach the critical concentration, it is no longer going to absorb the elements. So we need to replace the plants. So when it is in a building and it's in a limited area, it is very easy for us to remove these plants and plant the new plants again.
So that's it on phytoremediation. We hope that the video has been informative. Thank you and have a nice day.